So the first thing I want to do is come up with a list of my possible rational zeros. So I need my p's and my q's, and I'll put them together to form my possible rational zeros. Now remember, p has to be a factor of the constant term. In this case, that's negative 16, although I'm going to list plus and minus for everything, so I can just work with 16. It is sometimes easy to remember that with p and q, one of them has to go into the constant, and one of them has to go into the lead coefficient, but to forget which is which. I find it helpful to just use a very simple example to remember. If I have x squared minus 4, x equals 2, which I could write as 2 over 1, is a 0, because 2 squared minus 4 would give me 0. Okay. And I can see 2 goes into 4, but it doesn't go into my lead coefficient, which is a 1. So this very simple example reminds me that the number on top has to go into the constant. All right, so the p's are going to be numbers that go into plus or minus 16, so plus or minus 1 and plus or minus 16. What I'm doing here is I'm thinking of them in terms of pairs that multiply to give me 16, but I kind of like to have them written from smallest to biggest. So 1 will be the smallest, 16 will be the biggest. Then 2 works, so I'd have plus or minus 2 and plus or minus 8. 3 doesn't work, but 4 does, so I'd have plus or minus 4. And since 4 gets multiplied by 4, sort of my first factors were getting bigger and my second factors were getting smaller. Once they meet in the middle, I know my list is complete. Q has to be a factor of 3, so plus or minus 1 and plus or minus 3. So for P over Q, the numbers over 1 are just going to give me exactly what I have for P. So plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8, and plus or minus 16. And then I also have to list all of those over 3. So plus or minus 1/3, plus or minus 2/3, plus or minus 4/3, plus or minus 8/3, and plus or minus 16/3. It's a kind of long list. And unfortunately, none of these fractions reduced to give me things that were already on the list. That's okay. That's why we wanted to get really comfortable with synthetic division so that we can do it relatively quickly. All right. So I'm going to keep the p over q's up, just erase the p's and the q's, so I've got some room for my synthetic division. So it was 3x to the 4th minus 1x cubed minus 36x squared plus 60x minus 16. Quick check. Constant x squared, x cubed, x to the 4th. Yes. All right, I'm just going to try 1. Bring down the 3. Times 1 is 3. We add to get 2. We multiply to get 2. We add to get negative 34. Multiply and get negative 34. When we add, we're going to get 26, which unfortunately does not give us 0. And as soon as I can see it's not going to work, I can stop. Okay. Now again, because I've got limited board space, I'm going to erase this. You should not. Every time you do a synthetic division, that's part of your work, and part of the process is to try ones that don't work. Okay? If you just turn in on a take-home quiz something with only the synthetic divisions for the ones that work, it really looks like you Googled how does this factor and then only tried the ones that work. Don't do that. Just try them all. Every once in a while, the ones that work are the ones that you're likely to try first. But that's pretty rare. Usually there's a little bit of error in the trial and error. Okay, so I'm going to try 2. All right, we bring down the 3. Times 2 is 6. Add to get 5. Times 2 is 10. That gives me negative 26. Times 2 is negative 52. We add to get 8. Times 2 is 16, and that's very nice. That did work. So at this point, I know that m of x is equal to x minus 2. That would be the factor that goes with 2. And then this gives me the other factor, constant x's, x squareds, x cubes. So 3x cubed plus 5x squared minus 26x plus 8. And at this point, I can now get rid of the plus or minus 16 and the plus or minus 16/3. Because I'm going to keep trying to break this one down further, but I can check my list of possible p's and q's for just this factor the constant term is now 8. 16 doesn't go into 8, so I know that the top can't be 16. Okay. Can't still be 1, 2, 4, or 8, and the lead coefficient is still 3, so we could still have 1 or 3 on the bottom. Okay. But my list is a little bit shorter, and I'm now going to work with that polynomial. I don't need to keep trying things with the 4th degree polynomial. I'm now trying to break down 3x cubed plus 5x squared minus 26x plus 8. And as soon as I find one more, I'll be down to a quadratic, which I can either factor by inspection or trial and error, or I can use the quadratic formula. Okay, so let's see. I don't need to try 1 again because it didn't work for the whole thing, so it won't work for this. I am going to try 2 again, though, in case that works. Okay, so let's see. 3 times 2 would be 6. It's 11, 22, negative 4, negative 8. It worked. Awesome. Okay. I actually didn't realize that. I picked this problem, and I've got a teacher's edition, but for some reason the answer to this one was missing, and I didn't bother to look in the back of the book. So I didn't realize we were going to get a repeated 2. That's very exciting. So we'll have x minus 2 times x minus 2 times, now this encodes the last one. It'll be 3x squared plus 11x minus 4. Excellent. And again, I can try either to factor that or to use the quadratic formula. I'm going to see if I can't unfoil it. So, we've got our x minus 2 times x minus 2. If this is going to work, I'd have to have a 3x and an x to get the 3x squared. Now, the numbers that multiply to give me 4 could be 1 and 4 or 2 and 2. I kind of like the 1 and the 4, because if I put a 4 here and a 1 here, see, they've got to have opposite signs, but I'm going to get a 12 and a 1, and the difference between those is 11. I like that. I want positive 11, so let's make it positive 12 and negative 1. So that's 3x squared plus 12x minus x is plus 11x minus 4. Excellent. Now, if I had used the quadratic formula instead, notice the 2 zeros that I'm getting here is this would give me a 0 of x equals 1/3, and this would give me a 0 of x equals negative 4. If you got just those zeros, you would have gotten factors x minus 1/3 and x plus 4. Be careful, because those don't multiply out to give me this, because the lead term here would just be x squared. So remember, if you use the quadratic formula, you've got to look, what's my lead coefficient? If x minus my zeros are my factors, I'm always going to get a lead coefficient of 1, so I'd have to throw in an extra factor of 3 to make my lead term there be 3. And of course, if I distribute that, that just gives me back my 3x minus 1. So, multiple ways of getting there. Okay, so let's just record now all of our answers. So the real zeros, 2 is a 0, which happens to have multiplicity 2. This we said corresponds to 1/3, and this one to negative 4. And those are also my complex zeros. I didn't have any complex ones that weren't real. I sometimes will. Sometimes when I get down to a quadratic, I'll have to use the quadratic formula, and we'll get non-real zeros. Factoring over r and factoring over c, because all of the zeros were real, this is also the same thing. It's x minus 2 squared times 3x minus 1 times x plus 4.